Unit 2, okay? You guys saw how easy we went through Unit 1, took baby steps, took everything. I think everybody did well. I think the only thing that some people struggled a little bit on, and I think I might have, and if I haven't talked to some of you yet, there were some of the questions where you had to answer in sentence format. Just a couple of you guys got that a little bit confused, okay? But other than that, everybody pretty much, there's only a few of you that just need to get that taken care of ASAP, okay? All right, so volunteer first. No hands, no hands. Okay, Julie?
The 3 exercises in geometry, folding, cutting, and measuring.
Folding, cutting, measuring. Okay, that's good. Can you give me something else, though, that's really concrete, kind of like a rule that you might have gotten? That is important, though. Anything else that you highlighted?
Angles around the point add to 360 degrees.
All right, very good. Angles around the point add up to 360 degrees. Let's go to that one. Right here? Was that, or the front page? Oh, okay, right here. Angles, where is that? Right here. Angles around a point add to 360. Okay, very important. If you didn't highlight that, can you make sure you highlight that? That angles around a point add up to 360. As we start moving around and doing things, I'm going to pass out some figures to people, and we'll just keep rotating these out. All my toys. I want to make sure everybody has. These are not to throw around and play, okay? To touch and to have visuals. Okay, so nobody grab the ball. All right, does everybody have a figure? Anybody not have a figure? Everybody have a figure? Yes? All right. Wow. Okay. Let me get the square. Okay. So here's what geometry is all really, this whole class is really about you guys being able to, in your mind, like if you were to close your eyes, visualizing these figures in 3D, in 2 dimensions, flat surface, okay? We've got all kinds of geometric figures, okay? The key here that for you guys to keep making these tests feel easier is always trying to be able to visualize what type of figure or object the problem is talking about, okay? If you guys can start to remember that a problem is based off of some type of a figure, either 2 points or 1 point even, okay? But around any point, all the way around any point is always 360. That's very important. It's kind of like the basis of geometry, okay? The distance around a circle is different than going the total angle rotations of a circle or a revolution, okay? The distance around a circle is referred to as the circumference, assuming that you're talking about a straight line right through the middle, okay? All these figures that you guys have in front of you guys, they're all different. But they all have points that can make up a line, with the exception of this one. The circle is kind of special because it has a center of the circle, okay? Somewhere right in there. And then any point from the center to the circle on the circle, that's the radius. That's how far it is. if the circle is cut right in half, if you guys can see that line right there, okay, that'll cut the circle in half, and basically you're doing the diameter is a line from one point through the center to the exact opposite side, okay? All these things involve points and lines, okay? Right? And now we're going to talk a lot about angles, okay? So this is your introduction to this new unit, okay? All right, another volunteer? Okay, Tatiana?
And angles are will consist of a figure with a measure of some size and two angles with one angle.
All right, tell me where to go, up or down?
That's the first.
Okay, an unknown angle problem is a puzzle consisting of a figure with the measures of some sides and angles given with one angle, the unknown angle marked with the letter. Okay, that is important because we're going to talk about marking letters on a figure. We're going to try to figure out angles, okay? And we're going to try to look at things as if they were a puzzle, okay? All right, so that's good. All right. Evan, you got one?
Art of deductive reasoning, solidifies and studying the geometry.
All right, very important. Do I go up or down to get to that one? Up. Tell me when I got it. You see it? Here's first paragraph, second, third, fourth paragraph.
This is the very first one.
First one, okay, so it's in
Or
here.
like the top of the page. Oh, that. Third paragraph,
Third paragraph,
third sentence.
third sentence. I heard you say deductive reasoning or something?
Yeah.
Let's see. Is it somewhere right here? Do you see it? Oh, okay, thank you. All right. The initiate students in the art of deductive reasoning. Very important with that word.
That's the first part.
Okay. That's okay. Deductive reasoning. That's something we are going to talk about, and it's actually going to be on the test for this unit. There's two types of things that we do automatically. Remember the first class that we had? I had you guys do all the little activities with the birthdays and all those things, and I wanted to know about you, right? And the thing is, because when I look at people, I can't just assume that what I see tells me everything about the person, right? That's called inductive reasoning. When you look at somebody and you just assume something about them, that's called inductive reasoning. Deductive is when you actually go through the process of trying to figure stuff out. Okay? So you guys do those two things all your life. You've been doing that for a long time now. Okay? All right. Very important. All right, somebody else over here? Hey, Daisy, what'd you get? Up or down? Same page? Okay, what'd you get?
Angles with thin triangles and polygons involving parallel
Okay. Looks like we're right here. Angles. This one right here? Okay. Okay, facts about angles within triangles and polygons about parallel lines. Okay, everybody listen to these words. Angles within triangles. That's right off the bat. We're going to do angles about triangles, okay? We're going to work with polygons. Polygons are all these figures that you guys have. Now, does everybody see you guys all have different types of figures? Okay? All right. This one, with the exception, is special. Okay? Anything with a circle is exceptionally special. Okay? One would refer to them as polygons. Okay? There's a little bit difference about this. Okay? All right. It also states that about parallel lines. That's something that we're going to have to keep in mind. When two lines are parallel, their slopes are the same. Therefore, they never touch, okay? And what else did it say? Oh, okay, about congruent and similar figures. Those two words are very important. Congruent means the size and the shape are identical. If they're similar figures, one of them's a miniature version of the other one. All right? Okay. All right, let's scroll down. Everybody go down to this page, right? You're finding unknown angles. Okay? We're going to go through some of these activities, okay, and steps, okay? But let's go to geometry facts, the first list, okay? We're going to use abbreviations in this class a lot, okay? So as I'm going through lessons, pay close attention to when I start abbreviating things, kind of like a texting language. It's very important that you understand how to read some of the words I write, because it actually is another language, okay? All right. All right, everybody, let's go over here. Anybody highlight vertical angles? Everybody should have highlighted vertical angles, okay? If you didn't, please highlight vertical angles now. Okay, who highlighted it and can tell me about vertical angles? Somebody different that hasn't gone. That's right? Huh? Okay, vertical angles always have equal measures. What that means is, if they're equal, they're congruent to each other. Now, does everybody see the picture for vertical angles as a definition for a drawing? You notice it's just two lines that are intersecting? Yeah? Everybody do me a favor, you're just sitting down with your arms. Go ahead and pretend your arms are straight lines. Okay, go ahead and intersect them at a point. Now, if you change the angle that they're intersecting, you guys see the vertical angles that are opposite to each other? They're still the same size. You notice the two side ones on mine? These right here, they're smaller than the top and the bottom ones. Vertical angles are always going to be opposites of each other from two straight lines, okay? All right. Now, everybody take a look at the picture where angle A and angle B are identified. You guys do something? Draw. Okay, let's pick it up real quick so we can focus. There it is. It's underneath the other side of the tent in the back. All right. Okay. Now, everybody go ahead and take a look right here. Do you guys see the two lines? And these are exact opposites of each other, right? Does everybody see there's another pair that are exact opposites? Those are also vertical angles. They're just not linked right now. Vertical angles always happen when two lines intersect, no matter what. Okay? So do you see that it says A is equal to B right here? Go ahead and label this one then C degrees and D degrees. That's not an exponent to the 0 power. That's a symbol for degrees. How many degrees is all the way around a point? 360 degrees, okay? Angle A and angle B are vertical angles. They're equal to each other, but so is angle C and angle D. All right, did everybody label those on your handout? All right, okay, good. Put a big star here, because this is very important that you need to know what vertical angles are. If you ask me on a test, I forgot what vertical angles are, I'm going to say, hey, we took notes on it. You need to go back and check your notes, okay?
So it's easy, right?
Yes. This is like your cheat sheet, okay? All right. All right, go to the next one. The sum of adjacent angles on a straight line is always 180 degrees. Anytime you guys have a straight line, if there is two angles that are identified on that straight line, those two angles are automatically under the definition of a line. They have to add up to equal 180. which means you're going to be setting up some algebraic equations. Now you guys have already passed out, assuming. Okay? All right. All right, so this one is very important too, that two angles that are on a straight line should always add up to equal 180. Okay? Now this one right here refers to another, these are all very important, by the way. Okay? Now this next one says the sum of adjacent angles around a point is 360. Somebody gave me that as their first highlighted point, yes? Around a point is always 360. Here's that point. All the way around is 360. Now, in that picture, you guys notice there's, pretend that it was some type of dessert or something, and they sliced it up in 3 different spots. Those 3 different slices have angles within the center of it. Those 3 angles have to add up to equal 360. Okay? So we've got 2 things that we're starting to introduce to you about. We're going to set up equations that are going to add up to 180. Then we're going to set up equations that add up to 360. Okay? All right, everybody okay so far? We're basically, all we're doing right now is just kind of understanding some definitions and some terms right now, okay? All right. All right, everybody okay up to this point right here? Yeah? Okay. So let's move over here. I'm going to have to do this couple things. All right. Very, very important now. Now we're going to start talking about certain polygons, certain figures, okay? The first triangle that is discussed is the angle sum of any triangle. This is always true. The sum of any triangle, the inside angles, always add up to equal 180. That's a definition, okay? That is a definition. It is a rule that you're going to follow, okay? All right. Now, there's something going to be important that you guys are going to need to be able to do. You're going to need to be able to label where the angles are in a picture. Angles are different than side lengths. They're not the same. Okay? So this is called, the abbreviation of this is the angle sum of triangles. That's what that abbreviation is. Kind of like the texting format. Now here's important. If one of the angles of a triangle is a right angle measures 90 degrees. Everybody remember that word. Right angle and 90 degrees always go together. Yes? If it has a 90-degree angle, the triangle, then it's automatically labeled a right triangle. Does that make sense? So that's a very good question. Now take a look at the picture. Everybody look at the drawing carefully. You see where the 90-degree angle is? What symbol is representing the right angle in this picture? A little square. Yeah? Everybody see the little square right here? That represents a right angle. If you see that in a picture on any problems, then you have to already know this. That angle measures 90 degrees. Okay? So it's a lot about recognizing symbols. Okay? Do you notice it says that A plus B should equal 90? If one angle is 90 degrees in a triangle, the other 2 angles have to add up to equal 90. Okay? All right. Look at the abbreviation of it. Angle sum of a right triangle. Okay? This is the definition. If one angle is 90, the other 2 angles have to add up to equal 90. That means if you know one of these two, set up this equation and solve for the unknown value. Okay? Now back in algebra, you guys understand that in algebra you guys did a lot of solving equations and stuff like that? Yeah? Okay. Now, does everybody remember when I went over the graphing of the equations? Remember at first, when I first showed it to you guys, somewhere you guys were like, honestly, I don't remember how to graph it. After we went through it, there were several of you that felt, I can graph an equation that's in slope-intercept function. Yeah? Okay. All right, now, please put a big star by this one, because it's a rule that I need you guys to understand always. Now, it's a little bit interesting, this rule. If you were to look at one of the vertices, now the vertex that I just highlighted on the screen, what letter corresponds to that vertex that I put a green dot out by? What letter? A. But that's vertex A. This vertex right here, where this line and this line intersect, that's vertex C. Over here, there's a point D somewhere. This vertex is for the letter B. Now, do you see the vertices? There's also angles. There's angles here. And then there's this angle on the outside. That angle, do you guys notice it's clearly not inside of the triangle, this one that I'm going to highlight? That angle is clearly not in the triangle, yes? Now, this exterior angle on the triangle is always going to be equal to the opposite two interior angles. You see this angle right here? This angle plus this angle are on a straight line, aren't they? Those two have to add up to 180. Remember that rule earlier? Those two are adjacent angles. This rule, though, says angle A, an exterior angle, is always equal to the opposite two added together. So you're not going to use the angle right next to it, okay? You're just going to use the other two on the opposite of the outside angle, okay? Now, here's one thing I need you guys to kind of just, all you got to do is use your eyes, okay? Can everybody see if I extend this line, that's how this exterior angle was made? If I extend this line, the exterior angle is over here now. If I extend this line, the exterior angle is here. This angle plus this angle plus this angle should add up to equal how much? 360. Now those are not the only exterior angles though. Go ahead in your notes. Can you go ahead and label in your notes the exterior angles that I just showed? So please add this onto your notes. This is another actual rule. Now, you see how I shaded this piece right here, that piece, that's those three pieces that are shaded. You can use a highlighter if you want. Those are all exterior angles. On any figure, whether it's a triangle, a square, or even more sided figure, those exterior angles will always add up to equal 360. Okay? Exterior angles of any figure, figure, so that's the letter I forgot. Okay. of any figure at to equal 360 degrees. Does everybody see the symbol for degrees? It looks like it's exponent of 0. It's not an exponent of 0. It's just the symbol for degrees. Okay. All right. Degrees are not how you measure a line. That's when you use a ruler for that. Okay. When you use a ruler, you're not measuring in degrees. Okay. The only time you measure in degrees, it's when we start using these little devices. Has anybody of you guys ever seen these before? Protractor? Yeah. Right. Some of you guys already know how to use these? Yep. Yeah? Okay. Today we're going to do a little activity to make sure everybody knows how to use these stuff. Okay? All right. And remember, you notice I'm not doing too difficult stuff, right? Everything, though, is going to build so that when you do take this next unit test, though, it feels as easy as this last one that you guys just took. And then we'll be in Unit 3. Before you know it, we'll be done with the semester, hopefully before Thanksgiving, I think. And that way you can at least get an extra long break from math. Yeah? Okay. You guys are doing awesome. Keep focused when we're in here because I think everybody's getting everything. Yeah? Okay. Now I want to show you something. Everybody see the red angles that I shaded? You notice if I would have done this instead, extended this way, here's an exterior angle. Yeah? You notice if I would have went this way instead, there's an exterior angle. And you notice if I go this way, there's an exterior angle. What are these two angles called? Vertical angles. What about these two? Vertical. How about these two? So do you notice one of them went clockwise for exterior angles, the other way I went counterclockwise for exterior angles? So it doesn't matter, just be consistent on which direction you're drawing your exterior angles. Either you're going, you see this one is I'm going this way. The other one was I was going the opposite direction, counterclockwise. Okay. This angle and this angle are vertical angles. They're equal to each other. This one and this one are vertical angles. They're equal to each other. This one and this one are vertical. This one and this one are vertical. This one and this one are vertical. So that word, vertical angles, you guys got the hang of that one? Yeah, just as long as you see two lines extended, the opposite ones, they're congruent to each other, no matter what. No matter what. Okay? All right. All right, so far, remember, this is like your cheat sheet. This is your foundation, okay? All right. Can I erase it? Anybody need it? No? All right. All right, go to the next page. Does anybody remember one of the questions on the test that looked like this? Yeah? Some of you guys forgot. You didn't write isosceles, you wrote equilateral. Equilateral and isosceles are different. What's equilateral? Anybody remember? All the angles are the same and all the sides are the same. If you only know two sides are the same, that's an isosceles. Okay? If only two sides are the same, that means the opposite angles of those sides are also the same. Do you guys see the arrows I'm drawing from the two sides that are marked as congruent? Yeah. This side is opposite this angle, which is A. And this side is opposite this angle, which is B. I don't know anything about this angle at all that I just highlighted. I don't know anything about it. I do know that all three of them should add up to how much though? No, not in a triangle. What is that rule that we were talking about? In a triangle, they should always add up to equal 180. It's the exteriors that add up to 360. You can't mix those up, okay? All right. Everybody see this picture right here?
Yep.
That is equal lateral. All sides equal, all angles are equal, and the only angle that you can have for an equilateral triangle has to be 60, 60, 60. You cannot have any other equilateral triangle with angles different than 60, 60, 60. Okay? 60 plus 60 plus 60 is 180. It's the only equilateral triangle that you can have. Okay? The sides can be all big, all small, but as long as all the sides are the same, then it's an equilateral triangle. Okay? All right. The next part is the parallelogram. Now, a parallelogram means opposite sides are parallel to each other. This side and this side are parallel to this side. In a parallelogram, does anybody get the impression that this parallelogram looks like all the sides are equal? Maybe a little bit. If it is, all the sides are equal. In a square, all the sides are equal, yeah? But can you clearly see that the difference between a square and a parallelogram? The angles are shifted. In a square, all the angles are 90 degrees. In a parallelogram, opposite angles are equal to each other, which means this one and that one are opposites of each other, aren't they? Those, whatever they may be, they're also equal to each other. You okay? Yeah. It's very important because you're going to see these types of pictures when we get to the unit test. And you might have some variable expressions here, and you're going to have to write these two equal to each other. And then maybe you can solve for the variable. Okay? If you look at the next figure, it says interior angles between two parallel sides in a trapezoid. So everybody understand what a trapezoid looks like? Only one pair of opposite sides are parallel. These two sides are not parallel. Okay? If they were, then it would be a parallelogram. And this parallelogram is not a square. If all sides were equal, then it would be called a rhombus. Okay? Now, if all the sides weren't equal, and let's say these two are equal, but these two were also equal but different sides, that would either be that would be considered a polygon called a kite. Now, if you've ever flown a kite, you've seen kites that are made up like this. Yeah. That also looks like a diamond, doesn't it? If it's a diamond, all the sides are equal, which is what a rhombus is. Okay. All right. Now, one of the things that you got to pay attention closely on trapezoids, you notice that this angle and this angle add up to 180. This angle and this angle also add up to 180. Opposite angles are equal. So angle B is equal to angle D. Angle A is equal to angle C. If it's a trapezoid, okay? Now, hopefully you've noticed that on the test that I gave you on the last time, you got to really read the question carefully, okay? Make sure you read those questions carefully, okay? All right, so now that you have that information, does anybody need this? No? All right, so we're going to move to the first activity bit. All right, everybody take a look at this activity right here. I'm going to give this activity to you in just a minute, okay? But I just want you to look at it first. You notice it's just two lines. Two lines that are intersecting two lines that are intersecting always form what kind of angles again? Vertical. Vertical angles are always equal to each other. Yep. Do you see in picture number 1 another angle that also measures 45? Angle 4? I should have given everybody 2 pages. Should have given everybody 2 pages. There you go. Okay. Okay, the temperature is going to stay at that temperature. Okay. That's the best I can make it. I can't keep adjusting the thermostat. It will shut off at 32. Just bring a little sweater. I don't think it gets that cold, but that's the best I can make it. Because any other changes I make, it's either too hot or it's too cold. That's the best I can make it. All right. With your highlighters, okay, I want you to highlight angle 2 in that picture. Only angle 2. Does everybody see where angle 2 is? Okay, very important. These highlighters are to help you. Eventually, you guys are not going to have these highlighters. You got to be able to just identify the angle where it is on the picture. Okay? Okay. All right, go ahead and angle 2 is 45. Which one is a vertical angle to angle 2 then? 4. So angle 4 measures how much? 45. Okay, fill that in. Does everybody see I just put a little dot on the top right-hand corner when I wrote 45? That means the degree, okay? Or you can write the little 0 for the degree. That's fine. What do you guys remember that rule in the handout that you guys just read about unknown angles? 2 angles on a straight line should always add up to equal how much? 180. If one of them is 45, what should I do with the 180 in that number? How do you get that? How do you subtract it? And that gives you 135. Now here's how you can check. Go backwards. 5 and 5 give you the 10. Carry over 1. 4 and 3 is 7. Plus the 1 is the 8, and the 1 up is the 1. Yeah. So angle 1 measures 135. What about angle 3? That's the only one missing. It's a vertical angle to angle 1, is it? Angle 3. So angle 3 measures 130. Okay, did everybody feel comfortable with that right there? All right, can you guys do number 2 on your own real quick? Do number 2 on your own, and then put your pencils down. We'll go over number 2, and then if everybody's feeling that they get number 1 and number 2, then I'll let you do 3, 4, 5, and 6 on your own, okay? Just do number 2, put your pencil down. Some of you that are already like, oh man, this is so easy, I can do this, just be patient. That's good. I'm glad it feels easy, okay? Remember, I'm going to build off of everything though, okay? So as it keeps getting easier, just don't get so cocky that you're like, oh, I don't even need to pay attention. It's so easy. It's easy, that's great. I want it to feel easy, okay? All right, everybody got it? Pretty easy? Okay. Did you see vertical angles? Yes? Okay. One of them is given, right? That's this angle. So what's a vertical angle to 3? 1. So that means angle 1 measures 83. Okay, that was pretty quick. All right. Now, do you understand what I did right here?
Yeah, you subtracted the number
I subtracted this angle that I know
to 180.
to 180. So if I know angle 3, I know what angle 2 is, or I could say I know what angle 4 is. But do you notice 2 and 4 are vertical angles? So it doesn't matter which one you pick, right? So go ahead and do 180 minus 83, and you get how much?
87.
87?
97.
97. 180 minus 83. I'd have to borrow from the 1, the 8 becomes a 18, but I have to borrow from the 18, that becomes a 17, the 0 becomes a 10 now. 10 minus 3 is 7, 17 minus 8 is 9. That simple math doesn't take that long. Do that. Do me a favor, if it's that easy, don't do it in your head, just write it out. And you got calculators that you'll be able to use as well. My suggestion is always write everything out that you're doing, so that way if your answers don't make sense, it's a lot easier on a test for me to say, hey, go back and check that one. There's something wrong that you're not looking at right there. Yeah? Because that's all I can really do. So angle 2 measures 97, and so does angle 4. Everybody feel comfortable with those two right there? Yeah? All right, can you finish then those 4 underneath it for me real quick? And we'll review them in a minute or two, however long it takes you. Just put your pencils down when you're done with all 4 of those. I'm going to go ahead and erase them 1 and 2. If anybody needs it, can you raise your hand? 1 and 2? Nobody needs it up still? No. No? Okay. All right. You guys go ahead and finish then those 4 underneath it. And I'm going to get myself ready to set everything up. Don't start going over to the next page yet, okay? Just be patient. If it's easy, great. That's how I want you to feel confident that, oh man, this is so easy, I can do this. This test is going to be a breeze, okay? All right, so everybody on number 3, make sure you guys check. One of the things I noticed on the last quiz, some of you guys are not checking your coordinates on reflections. Your drawing was correct, but your coordinates on the reflection were off. So always check your work. Don't just rush through it to get out of here, okay? All right. And I can't always catch everything when you guys are doing a test. I'm just going to kind of glance at it and look. I think you're going to be good. Okay, that doesn't mean automatically you pass. Just things by me looking at it, because I just take a few seconds, it's just me thinking, I think you're good, you're going to be fine. If you don't pass, I will let you know. Okay? All right. Number 3, though, you understand 23N 157, 180. So here's how I check it. Here's my actual equation for it. Okay? All right, somebody different for number 4. Hey, Daisy, what numbers can you tell me are vertical? If you already know angle 4 is 82, which one's vertical for angle 4? Everybody agree those two are vertical? So that means this one measures what? 82. And what did you get for angle 1? 98. That means angle 1 and angle 3 are vertical, right? Can I check that these two are correct? Angle 1 plus angle 2 should add up to equal 180. So 82 plus 98, that's 2 and 8, that's 10, for angle 1. 9 plus 8 is 17, plus 1 is 18. Yeah? Okay. Vertical angles, does everybody understand how to recognize which ones are pairs on vertical angles? That's super important when you guys move on, okay? Take a look at the work that I'm showing you guys for numbers 3, 4, 5, and 6. Are there any questions on those measurements? No? Okay. And the reason why you highlighted it is because you need to pay attention to the order of the letter. This says angle AOC. You can also write it as angle COA. It means the exact same points. You notice it's still talking about this point, and this point only? This is where a lot of students sometimes get thrown off if they don't learn this little basic skill, how to read this writing. This says angle COA, okay? Now, does everybody see where I put the 80? Okay, go ahead and fill in this angle where COD is. You don't need to highlight it, just fill in where angle COD is. Which slice is it?
One for the next one.
Or the one right next to it. All right, everybody okay right there? Now here's the reason why we're doing this. Does everybody see this line right here? How much does a straight line total always? That means this angle plus this angle plus this angle should add up to equal how much? 180. So here's now where the algebra starts to pop up. That's really 80 plus 60 plus 2x equals 180. Write that equation down. Write that equation down. I have the exact same space available as you have, okay? Now before I do anything, remember the first handout I had you guys reading, and I said, read it carefully because everything that we're going to do is going to be based off of that handout, okay? That's your foundation, okay? If you need to go back and review and read that handout of the unknown angles again, I would suggest you do that, especially if you know you're not able to recall some of the rules already. If any of you guys are already having trouble recalling a rule that we went over, you need to go spend time and do more repetition. Some of you guys learn better when you repeat something several times. Yeah? Okay. All right, now I just wrote an equation. You guys are in geometry. The basic rule of geometry, and I gave a diagnostic almost to everybody in here. Those of you that did not take the diagnostic, at one point that should have been done, but it's too late, we have to move on. Those of you that did take the diagnostic, I let you know that there's going to be equations in this class, and I told you there's some basic rules that you need to remember. So those of you that didn't take that diagnostic, all I can tell you is go talk to your teacher why didn't they give you that diagnostic. Because I gave everybody a month before the class started to give it to you, okay? And that diagnostic was for me to know who's already going to struggle so I can start helping you now, way before the class has started. But now the class has started, we're already done with Unit 1, we're on Unit 2. What do I do now? You have to put in extra work in, okay? So here's the first thing about solving equations. Two sides of the equal sign, combine like terms on one side, but you got to look for parentheses if there's any distribution. There is no distribution that needs to be done. These two terms are similar terms, aren't they? So what do those two terms give you? 140. Guys. Okay, what would I do next? Okay, subtract 140 to both sides. That'll get the 2x by itself equal to how much? 40. You're not done, you haven't solved for x yet. X is equal to 20. The work I've just shown to you. A lot of people every year they tell me, I did it in my head. I can do this in my head. That doesn't mean I'm teaching you anything. I can give you the answer. Here it is. Is that going to help you? No. So I always tell you, do the same for me then. When you're doing work, show me it. Because I don't ever just give you the answer, do I? I give you steps. I show you what I'm doing. And I need you to do the same thing for me. Okay? Because I don't know. Some of you guys solve things different ways, and that's great. Just show me how you're doing it. That's all. Okay? All right. Take a look at that problem. We just solved it. We just did some algebra. If you weren't paying attention now, this is where people are going to start to lose it. Don't lose focus now. The first quiz, most of you guys breezed through it. Don't let this next quiz slip from your fingers. Keep focusing, okay? Are there any questions on that first problem? This is a foundation right now, guys. This is a super critical, important point right now. Okay, can you guys do the second one on your own? Yeah. All right, go ahead and do number 2 on your own. Put your pencils down when you're done with number 2. Let us go over the number 2 before you move on any further. Don't start getting too confident that everything is good. Let's just be patient. I will let you loose after number 2 though, okay? And before I do anything, I think there's some of you I didn't check, but did everybody understand the first part of the setup? Yes? Okay. You notice I put in parentheses where x plus 2 is? That's good. I just want you to keep doing that because really, whatever x plus 2 is, that represents this angle here. We don't know what it is though, okay? So just be aware. That's good that you do that parentheses just so you're separating it. It's this plus this one plus this one. Those 3 things are angles, or you can look at them as slices. Those 3 things should add up to 180. Remember that first rule in the handout? Yeah? Okay. Now, you don't need that parentheses after this part. These 2 give you the 135. Is that right? Yeah? Okay. Right there, you don't need to put the parentheses anymore. You can just write it like this, because technically this is really a plus 1 right there. Unless it would have been a minus sign, that would have changed the parentheses, okay? So right there, if you combined those 2 right there, that's fine. Or if you subtracted the 135 and then subtracted the 2, it's still the same thing, okay? 135 and 2, they'll give you 137, don't they? And then you take away the 137 to both sides because you're trying. Here's the whole point of solving equations. Get the variable alone by itself and move everything else to the other side, okay? What's 180 minus 137? Everybody help me? 23? 43, is that right? Everybody getting that number? Yeah, okay. X is 43. This angle measures 43 plus 2, which is 45. Okay? But all you had to do was solve for X. Now, if it asks you, what is this angle that's missing? Then it's 43 plus 2, which is 45 degrees. Yes? Okay. Everybody feel comfortable with that right there? Tatiana, we're good? Yeah? All right, can you do the other 4 on your own then? Yeah? Do the ones on the bottom real quick, and then put your pencils down. Okay. All right, does anybody need this work up here still? No? No? Okay, so I'm going to go ahead and erase. So for problem numbers 3, 4, 5, and 6, I'm going to do my work for number 6. There were no questions on 3, 4, and 5 though. So on the first one, as you guys highlight the angle, and then count from 0 going this direction, and then you counted the marks, which gave you 70 plus 4 marks to give you the 74 degrees. You're trying to get number 2 now. Now, on number 2, if you notice, you're going to count from 0 going this direction. with the protractor. So you're going to use the numbers on the bottom, not the numbers on the top, okay? But everybody go ahead and put your answer. And does everybody see I'm going to use these numbers right here? The angle is clearly more than 50 degrees. Everybody agree?
Yep.
So now you gotta, is it right in the middle between 50 and 60?
Yes.
Yeah. So that means it's 55. 55. And let's put the symbol for degrees so we get in the habit of that, yeah? Okay. Everybody okay with this one right here? Yeah? All right, can you finish the rest of those for me real quick and then put your pencils down? You already did? Okay, good. This should have been a super easy activity, but it's just to make sure that you know how to read these protractors. So go ahead and do the rest of them then. So you highlighted it.
We start zero. Once we check where it is zero, opposite zero. We will start this way. Oh, there's two numbers. There's numbers on the top. So you got to figure out which one is it. So I think since the angle is clearly on this side, we'll start with 0, 9, and 7.
Hey, most of you guys are already done. If you're done, that's great. Just maybe if you can help somebody, maybe if they're struggling next to you.
Oh, nice.
I put up the answers for 3 and 4. Can you guys check your angles? You guys already got 1 and 2, yes? Go ahead and check 3 and 4. Some of you guys, if you're not done with 5 and 6, I'll give you about a minute, okay? And then I'm going to put up 5 and 6. Am I off on any? If I am, let me know, because you make mistakes, okay? Right, everybody should have checked their answers for 5, 6, 7, and 8 now. All right, this is the handout that you guys are working on right now. One of them is an estimation, one of them is an exact measure, okay? My big protractor. All right, wherever you're at, let's go ahead and, if you haven't got your folder, go ahead and grab your folder and let's have a seat. I'm going to put up the answers on these. If you are struggling with any of these, answers for numbers 1 through 4. Everybody check your answers, please. We'll be out in 1 minute, okay? Check your answers. Now I'm giving estimates. If you estimated between 30 to 38, that's anywhere in between there is fine. The exact measure for number 1, though, was 34 degrees. If you're off by a few degrees on the exact measure, that's okay. Can't be off by that much, and this is where we got to make sure you're using these protractors correctly. This line should match with that line that's on the bottom right here. Okay? When you're doing these, if you're not doing that, that's why you're going to be off. You guys can't rush through these. Okay? You got to make sure the lines are matching and the vertex point is right there at that point, okay? All right, take a look at 6 through 8. Now, if you're not getting these answers, and there's a lot of them that you're not getting, my suggestion to you is stay for a minute or two so we can go over this. Don't just take off. If you're not getting this, stay for a few minutes so we can go over this, okay? All right, everybody else, those of you guys got checked your answers, go ahead and put your folders away. If you guys know you're not getting these answers, do yourself a favor, just stay for a few minutes.